Welcome back to Trig integrals. This is part 2 of the series of trig integrals that I'm doing in preparation for the test in 2 days on Friday. So I'm going to do a couple problems just two off of worksheet number 4. And if you don't have the worksheet because you're not in the class or something, you can still follow along. And again, I encourage you to pause it before I actually start doing it. After I've written out the problem, try it yourself, see if your answers work out the same as mine do. So we've got 2y dy over dx equals 5x minus 3 sine x, and y of 0 equals 2. I haven't actually done this one beforehand, which is kind of new, so this might be, you never know, this could get a little messy. So we have 2y dy equals 5x minus 3 sine x dx. So we're going to take the integral of both sides. Integral of 2y dy is just y squared equals, it's actually y squared plus c, but I'm going to subtract that over. So we have derivative, or integral that is, of 5x. So this goes to x squared, so it's going to be 5 halves x squared because you divide 5 by 2. Minus, well, let's see, we have negative 3 sine x, so integrating that would give us positive 3 cosine x. Because the integral of sine x is negative cosine x, and negative negative equals positive. Plus c, but I'm subtracting that one over to make it plus c over here as well. So our answer here is y squared equals 5 halves x squared plus 3 cosine x plus c. And I've never done this, so I'm just looking it over just to make sure I haven't screwed anything up, made a fool of myself. So y of 0 equals 2, that's the point 0, 2. So we want 4 equals, well, that's 0. Cosine of 0 is 1. So we have 0 plus 1 times 3 is 3 plus c. So c equals 1. So right now we have y squared equals 5 halves x squared plus 3 cosine x plus 1 as our final answer. And the thing you should get out of this is that, you got to move stuff over, and then you can integrate them. So 46, this is a little more difficult of an example. So we have dy over dx equals root of y squared plus 1 over y cosine of x, and it gives you that y of pi equals root 3. And I did do this one beforehand, so it shouldn't pose any problems. So basically we're going to multiply the y over here, so y times y squared plus 1. It'd be 1 over y squared plus 1 because we'd be dividing it, which just means that it's to the negative 1/2 rather than 1 over y squared plus 1 to the 1/2. dy equals cosine of x dx. So we're going to integrate both sides. Here we have to do u substitution, so u equals y squared plus 1. du equals 2y dy. So we only have y dy here, so 1/2 du. So right now we have 1/2 integral of u to the negative 1/2 du equals, and integral of cosine of x is sine of x. And I'm going to leave plus c here like we're going to subtract it from here. So right now we have 1/2. U is going to go to the 1/2 here because you're adding 1. 1 divided by 1/2 is 2. Those cancel. You get 1. So you get u to the 1/2 equals sine of x plus c. Well, we can plug this in now. Y squared plus 1 to the 1/2 equals sine of x plus c. So I'm going to square both sides so we can get y squared plus 1 on its own. So we're going to do y squared plus 1 equals, now this is the hard part. This is where I got confused and I've had to pause these videos before, because I'm not sure if it's sine of x plus c squared, or if it's sine squared of x plus c. And I came to the conclusion that it's actually sine of x plus c squared. And this is actually a part of it I haven't done before, so I'm going to have to approach this cautiously. So we have the point pi root 3 in here. And this should be fine. So this is y squared equals sine of x plus c squared minus 1. So y squared is root 3 squared equals 3 equals sine of pi. Well, if you remember, pi is over here, so sine of pi is 0. This is just c squared minus 1. So c squared equals 4. C equals plus or minus 2 in this case. There's actually two equations for this one, because you could have y equals, where is it? Y squared equals sine of x minus 2 squared minus 1. That's supposed to be minus, and you get y squared equals sine of x plus 2 squared minus 1. So I guess there's two equations here that you have to be aware of. And I guess leave a comment if you think I did this completely wrong or something. I guess there's always a possibility, right? So yeah, that's all. Those are the two examples. I doubt we're going to see anything like this on the test. So I think we should be, all good to go. So, drop a comment, drop a like if you enjoyed the video, and thanks for watching. This has been Trig Integrals Part 2.